So hello everybody, welcome to my YouTube channel. So we know that we are going through the series of video lectures on machine learning. In today's session, in that continuation, we are going to discuss about signal and noise, which are very important to understand the various techniques of machine learning. So firstly, we will try to understand what does it mean by signal. So if you could only sample one local school, like we say, the relationship might be in that case muddier. We are not clear about something. We say the signal is weak. It will be affected by certain outliers or anything. So signal is simply the true underlying pattern that you wish to learn from the data. So if we are able to get the correct learning from a data, then it means we are getting a good signal. So when we talk of machine learning comes in, a well-defining algorithmic model separates the signal from the noise. Where noise is nothing else, it simply refers to the irrelevant information or randomness in the data set. So when we talk of these things, so we can get that idea that what is actually happening in that case. So here we are going through a curve which is saying along the x-axis we have signal strength, less signal, more signal, and along the y-axis we are having less noise and more noise, further so on. So when we talk of signal versus noise, so when we say there is more noise, means too much disturbance is there and we are not clear about the information, and that is the case when we have very less signal, more noise, then we know this is a condition of obscurity in which the information that we actually want to get is not at all. This is the most dangerous case when we have very less signal and more noise. Now let's reduce the signal further. We are having signal less, but we are also having noise is also less. So in that case, this is a condition of mystery. Like we say, we are not getting the actual information. Also, there is very much disturbance as well. The disturbance is also there. So that is the case. There is a condition of mystery. Again, we are not able to understand anything. So we proceeding towards further. Now let's improve the signal, means getting the signal high, more signal is there, and at the same time more noise is there. So when there is more noise, more signal, then that is distraction, because this is the case we are able to understand, we are having good knowledge, we are having good facts about that, but at the same time there is noise is also there. So that noise will distract us. Like we are watching a very good video, and in that video we are having very good knowledge, it's interesting, each and everything is clear in that, but at the same time there is some disturbance in that. So in that case we will get distracted towards the noise also. So that's why, like suppose a teacher is teaching in the class, he is delivering excellent content, but at the same time there are some disturbing elements in the class who are creating noise. So in that case, what is happening actually, the other students who are trying to listen something, they will get distracted with that noise. So the best condition is when we are having very less noise and at the same time the signal is more, means all content is, everybody is sitting silent and they are trying to listen what is being delivered in the classroom, so they will learn more. So that is the condition when we get clarity. So the best thing is when we have less noise and more signal, but the condition when we have more noise and at the same time less signal, that is the worst condition. So when we talk of an algorithm that is too complex or flexible, it has too many input feature, or its property is also regularized, it can end up memorizing the noise. So this is what is created and known as mystery in the case. Let me repeat mystery again. So it says if the algorithm is too much complex or flexible, so like it has too many input features and it's not properly regularized, means it is suffering from the noise also, it will help up ending with the distraction. learning. This is a stage having good signal but noise also. So that is distraction condition, and it will memorize the noise. The overfit model in the case will make predictions based on the noise. So if there is noise in the data, then it will end up simply with making the predictions on the noise, and the model will be overfit. So we have another video on overfitting and underfitting. So for further clarification on that, you can go with that video. So let's discuss about the outliers now. Now we are aware of what is signal and what is noise. There is another very dangerous thing that is known as outliers in the case. So here we are not concerned about what is there in x-axis or what is there on the y-axis. It is simply random data. So in this case we can say these are going into a particular track, but this is a point that is lying outside. So this is the condition which is known as outliers. So when we talk of outliers, so outliers are simply defined as extended values, means they are out of the defined range. So if any values is going outside the range, then that is the case when we call it as outlier. So the extended value comes under the category of outliers. So let's understand with the all outliers with an example. So here let's take the case. So here we are taking a case in which we say we are having data like 20, 30, 40, and then 150 or 1500. Now when we talk of this data, here in this case we simply say we are dealing with the outliers. How these are outliers? If this is the case, just a minute, sorry. We are having 20, 30, 40, 50, another value as 1500. Now this 1500 is extended value. So if they are all thing points are lying over here, this 1500 will lie somewhere outside the range. So this 1500 in this case will act as outlier. Now on the other hand, if we say 20, 30, 40, 50, and there is another value, let us say ABC. So this ABC is not the extended range, this is totally a different value. So this value over here is known as noise. So if there is unwanted value, unwanted data that is totally out of the scope is coming in the category of noise, and if there is any extended value, it is coming in the category of outliers. So in this case we can say we are having two groups of the data, and two classes are there. Class 1 red circles, class 2 blue plus values, and this is the boundary line, and there is a red value that is lying outside the group, too far from the other values. So this is the outlier. Now but in this case we are doing classification. There is one class of red from this boundary line, and other one is blue plus, and this red which should be belonging to this class but is lying in other class, that is in the category of this plus blue plus. So in this case this is treated as noise, because this in this class above this green boundary line, decision boundary line, we are having all the values that are blue pluses. So there is some value that is not in this case, so this is a noise in this case, and outlier is simply the extended value. So this is about outliers, noise and signal. So with in the next session we are going to discuss about voice and variance, as well as we will be discussing about underfitting and overfitting, and what is about the best fitting. So if you like the video, you can subscribe my channel for further notification. So thank you.